Welcome students. Today we will going to start our physics syllabus, and firstly we will going to discuss about the definition of physics. Our physics is a very beautiful science, and it deals with the study of the nature and the natural phenomena occurring surrounding us. And in the physics syllabus we will discuss about the various phenomena that is occurring around us, like how we communicate with each other, how the frictional force plays an important role in our daily life, how we can do work. Work is positive, either negative or zero. So we have to discuss such kind of phenomena, and we have to relate these phenomena with our daily life also. So while studying the physics, we will going to discuss about the applications of the physics also. Okay. So firstly we will discuss about the fundamental forces which are present in the nature. We have four fundamental forces in nature, out of which we are going to discuss two of them. We are going to discuss today, and other two we will discuss in the next lecture. So let's start with the fundamental forces. This is the definition of physics. It is defined as the branch of science which deals with the study of nature and natural phenomena occurring around us. Okay. First, the fundamental forces. Fundamental. What the term fundamental means? Fundamental means a quantity which never changes. Okay, which is universal. That is known as fundamental. I am writing here the term fundamental. It means the forces, fundamental forces means that the forces which we are talking about do not change space to place to place. They remains the same. Okay, the fundamental forces. So today, first we going to discuss about the gravitational force. Gravitational force. As we all know that gravitational force is an attractive force. Okay, according to the Newton's law of gravitation, the force of interaction between the two heavenly bodies is directly proportional to the mass of the body and inversely proportional to the square of the distance between the bodies. According to Newton's law, if we have, suppose we have two masses m1 and m2 separated by some distance, suppose the distance between their centers is small r, then the force of interaction between these two bodies, or let me correct, the force of attraction between these two bodies is directly proportional to the product of masses, and it is inversely proportional to the square of the distance between them. So the force F is directly proportional to m1 m2 by r square, and when we remove the symbol of proportionality, then we have a constant which is known as universal gravitational constant. Universal gravitational constant, and its value is 6.67 into 10 raised to power minus 11. Okay, this is our gravitational force. Let's now discuss about the properties of the gravitational force. Gravitational forces are the weakest forces. Properties of gravitational force. Okay, first of all, gravitational forces are the weakest forces. These are the weakest forces in nature. It means when we going to discuss about our next fundamental forces like electromagnetic force, weak nuclear force and strong nuclear force, we are going to compare them with the gravitational force, and out of them we will find that the gravitational force is the weakest force. Second one, it is directly proportional to, it is directly proportional to the product of masses. Product of masses ये क्या रहता है, masses के product के directly proportional. Okay, next one, it obeys obeys inverse square law. Inverse square law, as the force of attraction is inversely proportional to the square of the distance between the masses present. So we can say it obeys inverse square law. Next one is it is attractive. It is attractive in nature. Okay, the gravitational force is attractive in nature, so it will always attract the bodies present around us. According to this law, the heavenly bodies always attract each other with a force of gravitation. Okay, next one is it does not depends upon the presence of third body. Presence of third body mean to say, if we have two bodies having masses m1 and m2, and the gravitational force between them is g m1 m2 by r square, and if we are having a third body here, suppose it have a mass m3, then the force of attraction between, suppose this body is A, B and this one is C, so the force of attraction between A and B does not depend upon the presence of C. Okay, this force between A and B remains the same. It will never depend upon the presence of third body. It means the force of gravitation will not depend upon the presence of third body. Okay, next is it is a long range force. It is a long range force. Okay, it is a long range force means that the gravitational force occurs even at a long range. We can observe it that the Earth is bounded with our Sun with a force of gravitation, and the separation between the Earth and the Sun is very large. So we can say that the gravitational force is long range force. Next one is it occurs due to the exchange of particles known as gravitons. Gravitational force occurs due to the exchange of particles. All the forces occur in nature due to the exchange of particles, and here in case of gravitational forces, the exchange particles are gravitons. Okay, so guys, this is all about our gravitational force. Now we are going to discuss our next fundamental force, which is known as electromagnetic force. Electromagnetic force, as the name of the force suggests, that it have two components. One is electric and other is magnetic. Okay, let's discuss about the electromagnetic force. Second one is electromagnetic force. Okay, electromagnetic force, the force existing between the two charged particles at rest is known as electrostatic force. Suppose we have two charged particles here, one is Q1 and next one is Q2, and the separation between them is R. The force existing between these two charged particles at rest is known as electrostatic force, and the force of interaction between two charged particles in electrostatic is given by our coulombs, and according to Coulomb's law, the force of interaction between two charged particles is directly proportional to the product of charges and inversely proportional to the square of distance between them. So when we combine these terms we have F is equals to Q1 Q2 by R square, and when we remove the proportionality symbol then we have a constant K which is known as electrostatic force constant, and its value is 1 by 4 pi epsilon naught Q1 Q2 by R square. Here epsilon naught is known as electrical permittivity of the free space. So this is the electrostatic force existing between the two charged particles. Okay, but we have to discuss about electromagnetic force. So this is the electrostatic, and the force existing between the magnetic poles is known as magnetic force. So okay, suppose we have two poles. Suppose this one is our north pole and this one is our south pole. The force existing between these two poles is known as the magnetic force. And if we have a charged particle which is moving in this region, then it will experience some force. So the force acting on the charged particle in the magnetic field, okay, the force acting on the charged particle in the magnetic field, it will have both the components, electric field as well as magnetic field. Then the force is known as electromagnetic force. Okay, so this is our electromagnetic force. Let's talk about the properties of the electromagnetic force. Like properties of electromagnetic force, EMF. Do not write it as EMF because EMF is a separate term. Electromagnetic forces. Okay, first one, it is again a long range force. It is a long range force. Electromagnetic force is a long range force. It is stronger than the gravitational force. That is, it is we can say it is 10 raised to power 36 times stronger. It is 10 raised to power 36 times stronger than the gravitational force. It means the gravitational force is very weak as compared to our electromagnetic force. Okay, now third one, it is a central force. It is a central force. Our gravitational force is also a central force. Central forces are those forces which acts on the center of a body to the center of a other body. Mean to say एक बॉडी के सेंटर से जो दूसरी बॉडी के सेंटर के ऊपर लगते हैं सेंट्रल फोर्सेस बोलते हैं. ओके, नेक्स्ट, इट इज कंजर्वेटिव इन नेचर. It is conservative in nature. It is conservative in nature. Conservative in nature means it does not depend upon the path followed by the body. It only depends upon the initial and final position of the body. Okay, it is a conservative force. Next one, it occurs due to the exchange of photons. It occurs due to the exchange of photons present between the bodies. Okay, here the exchange particles are the photons. So students, this is all about our first two fundamental forces, gravitational force and the electromagnetic force. In the next lecture we are going to discuss about our weak nuclear forces and strong nuclear forces. Thank you.